Zoom session is being brought to you by the Fractal Inverse Bullseye Horizon. All right, for today, we have the law of cosines, which will be useful for side angle side problems and side problems. We start with a triangle set in the coordinate plane. It has sides A, B, and between them the angle gamma, so therefore a side angle side problem. We want to find out the far side C. Later we'll figure out angles, but okay. So this length B is along the x-axis, so this far point is at B by 0, and this near point is at 0 by 0. This interval has length A, it has an angle gamma, so its coordinates are at A cosine gamma by A sine gamma. So we can find C as the distance between these 2 points. A cos gamma A sine gamma by A sine gamma to B by 0. All right, so C squared, simple enough. Take the difference of the x coordinates, A cos gamma minus B all squared, plus the difference, square of the difference of the y coordinates, A sine gamma minus 0 all squared. All right, now this comes out, so we expand this, A squared cos squared gamma minus 2AB cos gamma plus B squared plus A squared sine squared gamma. Now here we have an A squared cos squared gamma plus A squared sine squared gamma. We put them together. And cos squared plus sine squared is 1, so we get C squared equals A squared plus B squared minus 2AB cos gamma. This is the law of cosines. Now, the names A, B, C, alpha, beta, gamma are basically arbitrary. We give them to that. So if we swap them around, we should get similar identities. A to B to C to A, alpha to beta to gamma to alpha, we get 2 other identities. So, okay, taking square roots. C is root A squared plus B squared minus 2AB cos gamma. Swap them around. B equals root C squared plus A squared minus 2CA cos beta. Swap them around. A equals root 8B squared plus C squared minus 2BC cosine alpha. These are the law of cosines. These are for, because of the cosine function, of course. They're useful for side angle side to side. Given a side, an angle between, and another side, then this finds the third side. Excuse me. Liang. Welcome back. Welcome aboard. All right, now here's what we're going to do. We can take this, A squared equals B squared plus C squared minus 2BC cosine alpha, and solve for alpha. We transpose the B and the C. We divide by negative 2BC. We take an arc cosine, and we get alpha is arc cosine of B squared plus C squared minus A squared over 2BC. Now, okay, if you swap around labels like we did here, we get beta is arc cosine of C squared plus A squared minus B squared over 2CA. Gamma is arc cosine of A squared plus B squared minus C squared over 2AB. In each case, the angle is arc cosine of the sum of the squares of the adjacent sides minus the opposite side squared over twice the product of the adjacent sides. Now, the book doesn't give us a name, which is a pity because I think it deserves one. I call this the law of arc cosines. Given 3 sides of a triangle, it gives you the 3 angles. Very useful, in my opinion. Closest we got to that before was in side angle problems. So, for example, here we have a triangle with sides 6, 5, and 8. 6, 5, and 8. What are the angles alpha, beta, and gamma? Well, okay, here we go. Alpha is arc cosine of B squared plus C squared minus A squared over 2BC. So arc cosine of 5 squared plus 8 squared minus 6 squared over 2 times 5 times 8. After a bit of calculation, about 48.5 degrees. And of course, when you use arc cosine on your calculator, you have to be sure that you're in the mode you want. Degrees, say, or degrees or radians, just make sure which one it is. In these cases, usually it's degree mode you want. So beta, arc cosine of C squared plus A squared minus B squared over 2CA. That's arc cosine of 8 squared plus 6 squared minus 5 squared over 2 times 8 times 6. That comes out to about 38.6 degrees. Now, at this point, with these 2 angles, we could find the third angle by subtracting these 2 from 180. That would work, but it uses what I call slightly less fresh ingredients. I think it's better to you go from the original data, because pretty much any time you take a an approximation that by definition introduces an error. So to avoid that, we do this. Here we have, well, the problem was the plane goes due north 150 miles and then goes east at a bearing of 50 degrees east of north for 100 miles. So how far did it go? All right, now, if this is a bearing of 50 degrees east of north, and this, its supplement, is 130 degrees. So you have side 150, we have side 100, we have angle 130 degrees. So we use the original law of cosines. D is root of a squared plus b squared minus 2ab cosine gamma. So root 150 squared plus 100 squared minus twice 150 times 100 times cosine 130, about 227.6 miles. Oh, and then the question is, so it's got the plane as a result went 227.6 miles. But at what bearing? In other words, what angle is this north of east of north? Well, okay, we have a triangle. The side's 150, 100, and this is 226. So we can find theta, excuse me, by law of arc cosines. In this case, it'll be arc cosine of 150 squared plus 227.6 squared minus 100 squared, adjacent squared plus adjacent squared minus opposite squared over twice adjacent times adjacent, 2 times 150 times 227.6. And tick, 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 out of the calculator comes 19.7 degrees. All right. Now here we have a side angle side problem. This side B is 1, this side C is 3, this angle alpha is 80 degrees. What's side A, what's angle beta, what's angle gamma? All right, so first A, by law of cosines, root B squared plus C squared minus 2BC cos alpha, plug in 1 for B, 3 for C, 1 and 3, and 80 degrees for A. Do it all out, square root comes out about 2.99301. Which is pretty close to C. So these are actually fairly close to each other. So I'd expect gamma to be pretty close to alpha, pretty close to 80. And here we go. Now, okay, since we have all three sides, 2.99301, 1, and 3, then we can find beta, our cosine of a squared plus c squared minus b squared all over 2ac. Put it in here. And out comes about 19.21 degrees. Gamma, similarly, you have arc cosine of a squared plus b squared minus c squared over 2ab. So b squared plus a squared minus c squared over 2ba. And out comes 80.79 degrees, which is indeed very close to 80, as you should expect, seeing that A and C are very close to each other. So this is very close to an isosceles triangle. Well, okay. All right, that's pretty significant. So look at what we've done here. We have, from the previous section, we can solve angle side, by law of sines, we can solve, so let's see, angle side problems, angle side angle problems, and we can also, with a little difficulty, solve side angle problems. And then with law of cosines, we can solve angle side angle problems for the far side, and then use our law of arc cosines to find the other two angles. That's side angle side problems, and by law of arc cosines directly we can solve side problems. And that, I believe, is pretty much all the possible triangles. I mean, you could ask for an angle problem, but that's no good, because if you have three angles, all you know is the relative scale, the ratios of the sides. The triangle itself could be raised, or could be big or small of any size. So that's so between law of sines, law of cosines, law of arc cosines, we can actually measure triangles, and that is trigonometry. I think I'll stop this now. And